Today we're doing 1.5 A and B for the Accelerated Algebra 2 group. So last time you did exponents. Um, just hold on to those until I get back and then I'll collect them. But hopefully you've sent me the videos and those are all set. 1.5 A and B is just more exponents. So you have your warm-up right here in front of you. You should have this, right? These notes are in the corner. So if you don't have them, pause it and go get them. Just one page. I should probably say solutions. Oh well. But make sure you have this for the notes. So your warm-up is to do this one really quickly. Once you're done, resume the video and then pick up on there. All right, so if you've done this one, hopefully you got an answer of 1 over 8, a to the third, b to the ninth. Right, you would distribute the 3 to everything, but before you do, you could simplify. A squared over a to the third is a to the negative 1. So, that's 1a in the denominator, which is, and then multiply it by 3, so you get a to the third. B to the negative 1 over b squared will give you b to the negative third, so, or b to the positive third in the denominator. And then multiply that exponent by 3 to get 9. 2 to the third is 8, and the only thing left up there would still be the 1. Okay, so 1.5a and b are rational exponents. So again, we should be familiar with the term index. It's the number that goes inside the radical right there. Well, not underneath, but kind of inside there. Radical form, this would be radical form, and rational form is this form, where we can write it as a fraction, as an exponent. So this definition, so you have x to the m divided by n, you can rewrite that two ways. It's the nth root of x to the m, or the nth root of x, all raised to the m. It's the exact same thing. It'll always work both ways. Sometimes it's going to be easier to use this. Sometimes it's easier to use this. Most of the time it'll be easier to use the second one. So, like for example, if I gave you the third root of x to the sixth, that's already in radical form, right? Well, I'll fill in these blanks actually, hold on. So I have radical form would be the nth root of x to the m, or more commonly, there we go, nth root of x, and then all raised to the m power. And then rational form would just be x to the m divided by m as an exponent. So, I kind of wanted to see here. I thought I did a slide. Yeah, it's coming up. Okay, so if I said express the third root of x to the sixth in rational form, right? This is in radical form. What you notice is the number that's inside the index corresponds with the denominator. So n is inside the index, that's the denominator. M is what goes on the outside here, or inside the radical, the radicand, that's the numerator. So if I said to do this one in rational form, right, the denominator would be 3 because the index is 3, 6 would be on the top. So it would be x to the 6 over 3. And you can just say that as the same thing as x squared, which would certainly be a lot easier to work with. And you might not have been able to see that in this form, but rewriting it like this form can help you see it. And then if I said w to the 2/3 in radical form, right, the denominator is what's going to be the index, so it would be the third root of w squared. Might be easier if I do it this way. Or the third root of w, and then square the whole thing. Right? Both are fine. Okay, now what we need to think about is x to the m over n. When n is even, you have positive and negative solutions. And you might ask yourself why? Well, because if you have an even root, right, like a square root of, 5, that usually accounts for plus and minus because you created the square root, so you need to account for plus and minus. And it works the same way with a fourth root, because if you multiply a negative number, fourth root of 40 or something like that, right? If you multiply a negative number 4 times, it's still back to positive, so that just means if you take it a fourth root, or a square root, or a sixth root, any even root, you have to account for plus and minus. Odd roots, like if you had, negative third root, I'm sorry, actually, we have the third root of negative 8, right? There's only one answer. It's just negative 2, but it's not imaginary, right? So third roots will never create imaginary numbers. Square roots would. So even roots are the ones that have to do plus and minus. Odd roots, it's just what it is, right? If it's an odd root and there's a negative on the inside, it's a negative number. There's only one solution here. For our purposes, though, you only have to give me the positive with these ones. You don't have to really worry about it. I just want you to kind of keep it in the back of your mind. For when we get to Unit 2, you do have plus and minus. But for now, if you just give me the positive, I'll take it. So, just another slide when we need to do this. This is McLovin. But I read it because it's ID, right? It's fake ID. But ID stands for index denominator. And if you kind of remember ID, you'll never get confused as to which numerator denominator means what. So ID, index is denominator. That's all that you really need to worry about. The other one will obviously be the numerator. Right? So in this case, we have 8 to the 2/3. So 8 to the 2/3, right? That might not be able to tell by looking at it. Soon you probably will, but for now we're just going to rewrite it. So we're going to say, okay, well the index is the denominator, and the denominator is 3. So we're going to say the index is 3. And it's going to be the third root of 8, and then we're going to square the whole thing. Right, so the third root of 8 is 2, so you can take that. So take that first and then square it. So you would get 2 squared, which is equal to 4. Now, just to kind of show you, you could do it as a third root of 8 squared, which is the third root of 64, which is still 4. So you're going to get the same answer either way, but most of the time it's going to be easier to do that first way, especially when you can take it, right? If you can take the root right away, take it first and then square it. Or even if you can simplify it, do that and then square it, or cube it, or whatever you're doing to it. So 4 to the 1/2, ID, index is denominator, so the index is 2. So you don't actually have to write it, because we assume it's 2 if there's nothing written. And then it's 4, and then all raised to the first power. So you can kind of ignore that. You don't really need to write that, but you could. But the square root of 4 is just 2. And again, you don't have to write plus and minus 2 for this one, even though it's an even root. Just write 2 for now, and it's fine. 27 to the 2/3, so that's the third root of 27, which we can take it. So we'll take it first and then square it. Right, so it's going to be 3 squared, which is 9. And then the last one is going to be 9 to the 3/2. So index denominator, we can take the square root of 9. So we're going to do that and then cube it. So it's going to be 3 to the 3rd, which is 27. Right, so those are your answers there. These next couple are very hard. I want you to take a minute and see if you can do them. So try 5, 6, and 7. After you're done trying, go ahead and resume, and then I'll kind of go through these answers. Okay, so this first one, we have 5 to the 1/2, right? So that's going to be the same exact thing as the square root of 5. Right? We don't need to raise it to the first power. It's kind of redundant. And then times 45 to the 1/2. So 45 to the 1/2 is the same thing as the square root of 5. So instead of multiplying 5 and 45, I'm going to reduce the square root of 45 first. So I'm going to have root 5 times, and then the square root of 45 is the same thing as the square root of 9. Oops. Same thing as the square root of 9 times the square root of 5, which is 3 root 5. And when you multiply those together, you get root 5 times root 5, which is 5, times 3 is 15. The second one, we have 18 to the 3/2. So if I did 18 to the 3/2, right, I'm going to take the square root of 18, index denominator, and I can't take that, but I'm not going to cube 18 either, right? So I'm going to try and see if I can simplify what's inside first. And I can. The square root of 18, I can break up into the square root of 9, which is 3, and the square root of 2. Now, I can work with that. So since you're not adding or subtracting here, you can distribute the 3 to both. So 3 to the 3rd is 27. And then the square root of 2 to the 3rd power is the square root of 2 times the square root of 2 times the square root of 2. Right, so you're going to have square root of 2 times the square root of 2 here and here. It's going to be 2 times the square root of 2. It's going to be 2 root 2. So it's going to be 27 times 2 root 2, which is just going to give you 54 root 2. Final answer. And the last one, what do we have here? 54 to the 4/6. Well, your first step would say, okay, well, 4/6 can be reduced, and you can always do that. You don't even have to work with a 6th root or raising something to the 4th power. That's too much. So I'm going to say that's the same thing as 54 to the 2/3. Same thing. So now I can take the 3rd root of 54, and I can simplify that. So I'm going to square it after. Because the 3rd root of 54 is the 3rd root of 27, which is 3, and then the 3rd root of 2, and then squared. And this is where it gets tricky. You're going to square both, so 3 squared is going to be 9, and then root the 3rd root of 2 squared, so the 3rd root of 2 times the 3rd root of 2 is not 2, because it's a 3rd root. You'd have to multiply it again by a 3rd root of 2 to get to 2. So what's that final answer? Well, it's just going to be the 3rd root of 2 times the 3rd root of 2, which is the 3rd root of 4. Right? Nothing you can do with that. It's too small. Right? So that would be those 3 answers. So hopefully you got those, or at least figured out how to get those from that. Negative exponents. If we have a negative exponent, right, that first step is just going to change. So if we have 36 to the negative 3/2, we're just going to rewrite it so that it's 1 over 36 to the positive 3/2. So you're just going to flip it. So if it's in the numerator, like this one, 36 over 1, technically, move it to the denominator. If it's in the denominator, move it to the numerator. But you always want to work with positive exponents, so get rid of the negative first. And then from here, okay, you'd say the square root of 36, which is 6. So then you'd have 1 over 6 to the 3rd, and hopefully, we know that, it's going to be 1 over 2/16. That would be that answer. All right, a couple more practice problems here. We're going to try these 4, and then I'll try and give you these 2 to do on your own. These are a little trickier. But 64 to the negative 5/6, well, you're going to have to take the 1 over 64 to the 5/6. And now you're working with a positive exponent. So the 6th root of 64 is actually 2. And so if you're comfortable, you don't have to rewrite it as a radical. I'm not here. But you would do the 6th root of 64 first, which is 2, and then 2 to the 5th power, which is 32. So you're going to get 1 over 32. This next one, we have 27 to the negative 2/3. So you would write it first as 1 over 27 to the 2/3. And from here, you would take the 3rd root of 27, which is 3, square 3, so you get 9. So your final answer would be 1/9. This one and this one you guys can do on your own, so you can pause the video and then just check the answers when you're done. All right, so here we have another negative exponent, so we're looking with 1 over 16 to the 3/4. The 4th root of 16 is 2, 2 to the 3rd is 8, so you should get 1/8. Here, again, now this one with a fraction, with a negative sign, you just flip it. So you're going to be working with 49 over 9 instead of 9 over 49. And what that does is it gets rid of the exponent. So now it's to the 3/2. You don't flip this one. You just got rid of the negative. That's what it did. So square root of both, you would get 7 over 9 to the 3rd power each. So you're going to get 7. You take the square root of 49, which would be 7. So it's going to be 7 to the 3rd, and the square root of 9, which is 3 to the 3rd. And 7 to the 3rd is going to be 343 over 3 to the 3rd, which is 27. See if you can reduce it. You can't in this case. I think that's the final answer here. So again, now that we've gone over those, take a look at these 2, try them out, see if you can get them. Once you're done, resume the video and we'll go over them. Okay, so for number 5, we're going to work with 1 over 32 to the 3/4. Now the 4th root of 32 is not 2. The 5th root of 32 is 2. So you're going to have to do a little bit of work here. So I'm going to rewrite as a radical. I'm going to say 1 over the 4th root of 32, and then all raised to the 3rd power. So the 4th root of 32, a perfect 4th root you can take out of 32 is 16, right? The 4th root of 16 is 2, so it's going to be 1 over 2. And then what's left is going to be the 4th root of 2, 4. Right, so it's 2 4th root 2 for this one. And then you're going to have to cube all of that. So you're going to get 1 over 2 cubed, right? We can distribute the exponent to both. 2 cubed is 8. And then the 4th root of 2 cubed is going to be the 4th root of 2 times the 4th root of 2 times the 4th root of 2, which is simply the 4th root of 8. Didn't nullify, right? Didn't get to 2. You would have to have the 4th root of 2 to the 4th power before you get 2. To the 3rd power is just 8, not a perfect 4th root. Perfect 3rd root, not 4. So that would be your answer for that one. This one's even trickier. Get rid of the negative first so that you have 1 over 242 to the positive 3/2. And then we're going to take the square root of 242, index denominator. The square root of 242 and then all raised to the 3rd power. So the square root of 242 is not perfect, but 121 is, and that's half of it. So we're going to take out an 11, because the square root of 121 is 11. So then I have 11, and what's left would be the square root of 2. And then that's all raised to the 3rd power. So 11 to the 3rd power is going to be 11 times 11 times 11, which is going to be 1, 3, 3, 1. And then root 2 to the 3rd power, right? We just did 11. Root 2 to the 3rd power is root 2 times root 2 times root 2, which we did before. We got 2 root 2. So times 2 root 2. 2 root 2. There we go. So your final answer, 1331 times 2 is going to be 2662. And then root 2. Which actually, sorry, that's not your final answer, because you might see here you have a square root in the denominator, so you're going to need to multiply by root 2 over root 2 to get rid of it. So your final answer would be root 2, and then 2662 times 2 would give you, let me think here, 26, you would get 5, brain cramp here, 5, 3, I'm just going to do it, I'm cheating, that's okay. Okay, 3, 2, yeah, I'll still do it, just check. So we got second quit, we got 2, 6, 6, 2 times 2, yeah, 3, 2, 4, 5, 3, 2, 4, and that would actually be your final answer. Definitely a little bit of a doozy of a problem, but hopefully you'll be able to get it. Picking up where we left off. So we just finished this slide here. So when we look for when we have an equation like this, right? So we have parentheses, we have two different terms, and they're all raised to an exponent. It doesn't matter that's 1/3, it could be 2. It doesn't have to be a rational exponent. Anytime you see one of these, I think we know what to do, right? You cannot distribute the exponent, right? So if it was 2, you would have to FOIL. If it's 1/3, you just leave it like that. And that's as much as you're going to do for now. You could rewrite it as the 3rd root of this whole thing, 5 minus 2x, right? That's fine too, but that's the same thing as this. But what you can't do is never, ever, ever distribute exponents to both when you're adding or subtracting. Multiplying and dividing, that's fine. We've been doing it, up to this point anyways. But when you're adding and subtracting, treat it like a stop sign, right? The minus or plus sign is a stop sign. You cannot go any further. So that's just kind of what that slide's really saying. There's some other steps here that I think are in your notes. You can just look them over. Clear out all xi exponents. Yeah, we're just going to go through some of these problems. So if you need to, you can use these slides or pause the video and read through them. Make sure you understand them, but I think some examples are probably the best way to do it. So we're going to go into processing partners. Why don't we, well, everybody's probably going at a different pace, so ignore the partners. You guys can just kind of do it. Check with the people next to you, though, you know, when they get to this section, or if they're already there, you know, check some of your answers to make sure you know what to do. So we have radical expressions with variables. The index, right, so we're going to have, instead of just one term like we've been working, we're going to have, you know, a few different terms. You know, variables in there all raised to a rational exponent or all underneath the square root or cube root or whatever root sign. So what happens is when we do these, right, we're going to have some numbers. The index is going to tell you how many groups of a number you need to take out. Nice ones are going to work out nice and evenly. You're not going to have any remainders. And then the not nice ones, you're going to have remainders or leftovers. And then that's a check to make sure you do it right. But again, we're just going to do an example so this makes sense. So if I said simplify the square root of 36 x to the 12th, what you guys want to do, you can put a 2 in there, you don't need to. But think of it as the square root of 36 times the square root of x to the 12th, right? That's your product rule, right? You can break it up like that. So the square root of 36 is 6. The square root of x to the 12th, and this is what it's talking about. See how many times the index goes into the exponent. So 2 goes into 12 6 times. So we're going to pull out 6 x's, or x times itself 6 times. So the 6 is from this one. This exponent of 6 is because 2 goes into 12 evenly 6 times. That's what we say is like that nice radical. It went in nice and evenly, you're done. Right, now you could rewrite this as a rational and say, okay, it's x to the 12 over 2, which is the same thing as x to the 6th. But this way is going to help us out a little bit in the future. 2 goes into 12 6 times, so you take out x to the 6th. This one's written as a rational one, right? But I think it's probably better. You could here, since there's no adding or subtracting, you can distribute the 1/2 to everything. I'm just going to rewrite it as a square root. So I have the square root of 45 x to the 12th and y to the 5th, and the square root takes care of the 1/2, and then break it up just like we do this one. So square root of 45, which is 3 root 5, the square root of x to the 12th, which we actually just did right here, which is x to the 6th, and then the square root of y to the 5th, and this is where we haven't left over. So the index is 2. So you can say, okay, well 2 goes into 5 twice, so we're going to pull out y times y, 2 y's, y squared. And then there's a remainder of 1. So that remainder is not going to come out of the radical, right? So that y to the 1st, that remainder stays inside. The other ones can come out because, you know, 2 goes into 5 2 times. But then that last one is still stuck in there. So when you rewrite this, don't leave that as your final answer. Write the number first, anything on the outside first. So 3x to the 6th, y squared, and then group what's inside together. So you have a 5, put the numbers first, and then a y. So that would be the answer to that one. And then more practice, this will get pretty quick. I think you guys will be okay. So you can try this one on your own using the same kind of methodology. So pause the video and then resume it when you're done. All right, so we're going to have the third root of 48 x to the 3rd, y to the 20th, and you can break it up into each piece. The third root of 48, I can take out an 8 from that, so the third root of 8 would be 2, and then I'd be left with the third root of 6. The third root of x to the 3rd, 3 goes into 3 exactly once. So 1x is going to be on the outside. 3 goes into 20, 6 times, so I'm going to take out y to the 6th, and then you have a remainder this time of 2, right? 3 times 6 is 18, so you still got 2. So that index is 3, and the variable is y, and the exponent's 2. So 3 doesn't go into 2, so it's okay that you have y squared here because the index is bigger than the exponent, which is okay. So when you finally rewrite it, you would have 2x y to the 6th, and then you'd have the third root of 6y squared, and that would be your final answer. So hopefully you had that. We got 2 more slides. This one here, we have a third root of a negative number, so that's okay. It's okay to have third roots of negatives. You can really just think of this as a third root of negative 1 times 16, and then break it up that way. The third root of negative 1 is just negative 1, so really with a third root, you can just pull the negative right out, and it doesn't do anything. You don't compromise the number or anything like that. So the negative's done. Now I have the third root of 16. So the third root of 16, 8 goes into 16, so the third root of 8 is 2. And what's left would be the third root of 2. The third root of x to the 9th, if we look at this one, goes in 3 times nice and evenly. And then that y is also, again, not going to go in evenly. 3 goes into 13 12 times. 3 goes into 13 4 times. And there's a remainder of 1. So that last y to the first, or just y, stays on the inside. So final answer, negative 2, x to the third, y to the fourth, and third root of 2y. Again, never, if it's a third root or any odd root, never leave a negative inside. You can always just pull it out. Why? Because the third root of negative 1 is negative 1. So you can just pull it right out and just make sure you always kind of remember that. So you have classwork problems. You're just going to do the odds. It's on Schoology. It'll say classwork, and it's also your homework. It's like 2 worksheets and 1 attachment. So for now, go through the classwork problems, do the odds, and then for homework, do the odds on the homework. And then also you have page 417, numbers 21 to 32. And that should be it. If you don't finish the classwork, then please do those odds as well, just to save you from work. All of this stuff could be on a homework check, so make sure you get it all done. They should go quick. The more you get used to these, the quicker they'll get.